let's find out this limit. As n approaches infinity, this integral over logarithm of n, we're going to use Stodd's theorem. It says if bn is a real sequence, if it approaches positive infinity as n approaches infinity, then if the limit of this exists, right, the an plus 1 minus an over bn plus 1 minus bn, if that exists, then we can claim that the original limit an over bn exists. Doesn't matter if the an approaches infinity or not, or just bounded or whatever. As long as the bottom approaches infinity, then it's good. Even if it's positive, negative infinity, we just have to add a negative sign. So this is fine. So I'm going to treat the top as an, bottom as bn. So I'm going to denote an equals the integral from 0 to half pi of sine square nt over sine t dt. We can treat it as a sequence because the integral is with respect to t, and as n changes, the integral also changes. So bn is equal to logarithm of n. So the difference of bn plus 1 bn is simple, just logarithm. Let's quickly just work out bn plus 1 minus bn. This is simple, just logarithm of n plus 1 minus logarithm of n. That is equal to logarithm of n plus 1 over n, which is equal to logarithm of 1 plus 1 over n. As n approaches infinity, we're going to later replace this with just 1 over n as equivalence substitution. So we worked out the bottom, right? bn plus 1 minus bn. Let's work out the top. an plus 1 minus an. What's that? Now, an plus 1 minus an, what is that equal to? Since we have exactly the same boundaries, right? Let's just combine the integrand, right? The same boundaries. Integral from 0 to half pi. We have the same bottom, right? Sine of t. Top, we have to take their difference. But I'd like to change the top into, I'm going to reduce the power of the top. Remember, first of all, remember, cosine double angle formula, twice of, for example, nt. And treating nt as a whole entity, right? Double angle formula equal to 1 minus twice of sine square nt. Right? So therefore, sine square nt is simply equal to half of 1 minus cosine twice of nt. Right? So therefore, I can simply reduce its power down to just power of 1, right? Degree of 1. And I have 2 here, right? So twice. So first of all, sine, so this is equal to that. So sine, likewise, sine square of n plus 1 times t is equal to half of 1 minus cosine twice of n plus 1 times t. And like I said, I was going to take their difference, right? Difference, top difference. So in fact, this minus that, right? 2 already copied down here. 1 and 1 just cancel out. And this minus that, right? Which is equal to this minus that, minus positive this minus that. Right? So cosine of twice nt minus cosine of twice of n plus 1 times t, right? Twice n plus 1. Later, I'm gonna use the I'm gonna simplify the top, right? dt. We can simplify further the top using angle difference. Change the trig difference into trig product, right? There is an identity. Let's recall that. First of all, cosine alpha minus cosine beta is equal to cosine half of alpha plus beta. Alpha can be written as half of alpha plus beta plus half of alpha minus beta, right? So alpha twice of beta minus beta cancel out. This is indeed true. Minus cosine of beta can be written as half of alpha plus beta minus half of alpha minus beta, right? Alpha cancel out, beta minus beta plus beta, twice of beta. So this is true, right? So cosine for cosine beta can be written like that, right? Later, now we're going to use the the angle sum formula, right? Cosine, we have two angles, right? Angle plus angle. So cosine minus sine. Here we have angle minus angle. So we have this can be written as cosine minus cosine plus sine. Right? So the angle happen to be different opposite signs, right? If it's a plus, then we have cosine minus sine. If it's minus here, we have cosine plus sine. Therefore, in the end, here we have a minus sign. So cosine and cosine just cancel out. But here we have a minus sine coming out. There we have a minus of plus. Still a minus sine coming out. So twice of minus sine. So minus twice of sine. Sine of half alpha plus beta. Sine half of alpha minus beta. Right? So this is our angle identity, right? So cosine trig difference equal trig product. Right? So the top can be simplified down to a trig product. Twice sine t dt twice minus twice. Right, so minus twice. Minus twice sine alpha plus. What's alpha? What's beta? Alpha is 2nt. Beta is n plus 2 of n plus 1 times t. Right? What's their sum? Sum is 2n twice 2t. 2n plus 1 2t times 2t. 1 over 2. So 2n plus 1 times t, right? 2t extracted. 2n plus 1, 2 and 2 cancel out, 2t. Yes, that's the simplified down to this one. So alpha, half of alpha plus beta times, what's alpha minus beta? Sine. What's alpha minus beta? Alpha minus beta divided by 2. This minus that. 2nt. So 2t minus 2t minus t. Sine of minus t, right, equals minus sine t. Therefore, minus become plus sine t dt, right? And the 2 and 2 cancel out. And sine t cancel out. Now, just need to work out this integral, right? Just what's its antiderivative? Sine of 2n plus 1t. That is simply minus of cosine of 2n plus 1t. And we have to divide it by 2n plus 1 because there is a chain rule here. So let's just double check. Just differentiate it and compare it with this, right? So first of all, cosine minus sine, minus cancel out sine of 2n plus 1t, then times the constant. Use chain rule 2n plus 1 cancel out, equal to sine, exactly equal to this. So this is fine. It's antiderivative indeed. So evaluate it from 0 to half pi, right? So this is simply copy down 2n plus 1. What's minus cosine of so half pi, t replaced with half pi. Half pi times this can n pi plus half pi, right? If I'm correct. So plus pi, yes. Then replace t with 0. Right. So minus become plus cosine of 0, right? What's first of all, what's cosine of half pi? Cosine of half pi is just 0, right? And we have to plus a multiple of pi, right? No matter what that is, plus multiple of pi. So eventually it's going to be 0, right? So this is already 0. How about cosine 0? Cosine 0 is 1, right? Not 0. Cosine 0 is 1, right? Eventually we have 1 over 2n plus 1. Okay. So, yeah, so this is really the difference between an plus 1 minus an. Right? So we have both. We have, now we just have to work out the, work out this expression and see if that limit exists, right? So we just have to work out 1 over 2n plus 1 over bn plus 1 minus bn. Like I said, we work out to be logarithm of this, right? Logarithm of 1 plus 1 over n. Does the limit exist for this expression as n approaches infinity? First of all, I'd like to use equivalence substitution. Remember, the famous limit, right? The limit of x approaches 0 as log of 1 plus x over x is indeed 1. This is a well-known limit, right? Here, we can treat 1 over n as x. Remember, x approaches 0. N approaches infinity, meaning 1 over n approaches 0. Right? We can actually use this equivalence substitution. We can replace logarithm of 1 plus x with x because they're equivalently infinitesimal, right? So the bottom can be replaced with 1 over n, right? So we just have to work out, maybe let's use this symbol, you know, the approximate. So, right? Can be replaced 1 over n, right? Just need to work out if this limit exists. Now, this limit actually, obviously, I think right? 1 over 2m plus 1 over n times n, right? Times n. So is this one? This one is easily approaching half because the reason is because this is divided by n, right? We have 1 divided by n on the bottom. So 2 plus 1 over n, right? 1 over n easily approaches 0. Therefore, should easily approaches half as n approaches infinity, right? So in the end, we have half. Indeed, half. Our final answer. I mean, this perhaps I will prove Stott's theorem in a future video, but there are dozens of different proofs. This is just like a discrete version of L'Hopital's rule.